what is a relation? And when I was looking for a good definition of a relation, I kind of found a bunch of different ones that I thought they're all pretty good and they have different elements to them, so I just put a bunch of them there. So a relation associates the elements of one set with the elements of another set. That's basically a pretty good definition of what a relation is. It's taking something like elevation and relating it to time. Or something like age and relating it to height. That would be a relation. Or speed, distance traveled. All of those things are different types of relations. So it's just relating two different sets of data. A relation can be any set of ordered pairs. So when you see an ordered pair like an x and a y, that's a relationship, the way x is related to y. So a set of ordered pairs. Relations are often represented using arrow charts connecting the two sets of elements. We're going to talk about these arrow charts or arrow diagrams today. So that's a good thing to have in there. And a relation is a relationship between sets of information. That's pretty similar to the first definition. But those are, kind of put all that together and that's what relations are. We're going to look at different ways to represent a relation. And it's all going to be related to this one scenario. So this particular relation is the one that we're going to look at. And it's a relationship, as Caitlin rides her bike to school, the relationship between the amount of time that has passed and the distance that she has traveled. So it says Caitlin rides her bike to school every day. The table of values below shows her distance from home as time passes. A table of values is one way to represent a relation. So this shows the time in minutes, so how many minutes she's been riding her bike and how far she is from home. So at 0 minutes, she's 0 meters from home. She's still at home. Then she starts traveling 1 minute. She's 250 meters from home. After 2 minutes, she's 500 meters from home. After 3 minutes, she's 750 meters from home, and so on. That's one way of representing that relationship. And there are a bunch of different ways that we're actually going to do here. The first one says, write a sentence that describes this relation. For every minute that Caitlin rides her bike, she travels, where'd it go? 250 meters. This is pretty open when you're writing a sentence to describe a relation. Everybody's not going to have the exact same thing for that answer. But you should have something similar to this when you're describing that, because that's what's happening in this situation. Then it says represent this relation with ordered pairs. This is an exact thing. The ordered pairs would be time, then distance, right? So looking at the actual values, one ordered pair would be 0, 0. Another one would be 1 and 250. What would another one be? 3 and 750. Also 2 and 500. 4 and 1,000. And 5 and 1,250. Those are the 6 ordered pairs that we know in this relation. If this table of values shows the entire trip to school, then those are all the ordered pairs that we know, but there could be others that we could come up with. Like what happens at 30 seconds, a half a minute? What happens at 3.5 minutes or 3.25 minutes? What happens after 5 minutes? These ordered pairs are not the entire relationship. They're just the part of it that we're looking at. For the next one, represent this relation with an arrow diagram. An arrow diagram is also a very specific kind of thing. And you may not have seen one before. But the way it's going to work is you list all of the kind of X elements, the first elements, so 0, 1, 2, 3, 4, 5. We're going to make a list. And I'm going to call that time, so I'll put a T up above it. And for D, I'll list all of the distances, 0, 250, 500, 750, 1,000, and 1,250. For some relations, you might have the same number showing up more than once in one of those lists, and you wouldn't write it more than once, only once, and from smallest to largest. And then we put like an oval around it. And it's called an arrow diagram. We don't have any arrows yet. So then the arrows we're going to put in to show the relationship. 0 goes with 0. So we'll put an arrow across there. 1 goes with 250. 3 with 500. Sorry, 2 with 500. 3 with 750. Each pair gets an arrow. And this is a really simple arrow diagram because all of the numbers are just side by side because they're both increasing. But sometimes you'll have arrows going, maybe 2 arrows coming from 0 pointing at 2 different things, or arrows going up or down, whatever. But that's what an arrow diagram is. Then it asks us to write an equation for this scenario. And that's a little bit trickier. You could use what you know about linear functions, y equals mx plus b, because this one is linear. But if we look, it starts at 0, and we know that it always goes up by 250. So the equation would just be that distance is equal to 250 multiplied by time. So it's a direct relation, so it's just the rate multiplied by that independent variable. We're going to talk about independent, dependent variables in a minute. Then it asks us to graph the relation. So when we graph it, zero and 0. I'm just plotting the points. So can you see that little dot there at 0, 0? I think I'll make the dot a little bit bigger so you can see it better. And then we'll do one at 1 and 250 and so on. Plot all those points. And then we'll join them together because this is continuous, right?
Time, yeah.
It's time, it's continuous. She's not jumping from 0 to 250 in no time. It takes time to get there. And all those, there are actually an infinite number of points between the beginning and the end here because there's all those little points that make up that line. You've probably talked about this in science class. I think if you've taken Science 10 already, independent and dependent variables. But we'll go over it again here. An independent variable influences change in the dependent variable. The independent variable is just kind of there. The dependent variable depends on it. So if we're talking about something like the one we just did, distance and time, we have to think about which one depends on the other. So does the amount of time that's passed depend on how far she's traveled, or does how far she's traveled depend on how much time has passed? That one, the second one? That makes time the independent variable and distance dependent, because the distance traveled depends on the amount of time that she's been traveling. The time is just happening whether she's moving or not, right? It's going to keep going. It's independent of what she's doing with her distance. But as time passes, how far she travels depends on how much time has passed. That's the independent dependent variable. And you look at these questions, which is the other stuff that's on that sheet. For each scenario, state the dependent variable, the independent variable, and the rate, and then write the equation. Let's just look at the first one and try to figure out which is independent and which is dependent. So it says a fruit vendor generates a revenue of R dollars by selling N boxes of plums at $3 each. So it's R and N, it's revenue and number of boxes sold. Which one do you think is dependent and which one do you think is independent? So if you kind of make that sentence, one depends on the other, one of those sentences will probably make sense and the other one won't. So I could say the revenue generated depends on how many boxes he sold. Or I could say the number of boxes he sold depends on the revenue that he makes. The first one, which I said was the revenue depends on the number of boxes sold. Revenue is how much money he makes. And the amount of money he makes depends on how many boxes he sells, which makes the revenue the dependent variable and the number of boxes sold the independent. And I always think of making that sentence, this depends on this. I should be able to say that the dependent variable depends on the independent. So revenue depends on how much he sells. How much money he makes depends on how much he sells. Doesn't work the other way around. Now there will be some maybe that aren't quite as straightforward as that, but that's how I determine what's dependent and what's independent. And then it asks you for the rate. Well, it says $3 each, so the rate is 3. And to write an equation, revenue is equal to, it's always going to be dependent is equal to rate multiplied by independent. Not like always forever, but always for these questions. Dependent variable equals rate multiplied by independent variable. So R is equal to 3N. Which makes sense if you think about it. Say he sells 3 boxes of plums. How much money is he going to bring in? $9, right? Because it's $3 each. So 3 times 3. The next one is a runner with a speed of 9 meters per second can run d meters in t seconds. So, does the distance he runs depend on the amount of time he's been running? Or does the amount of time he's been running depend on the distance that he runs? Which makes which one dependent? And which one independent? The dependent is D, and the independent is T. Yeah, because the distance he runs depends on how much time he spends running. And then the rate was 9 meters per second, so the equation is D equals 9T.
Is it 9T or 9 meters per second?
I wouldn't, when I'm writing an equation, usually I wouldn't put the units in there. But it would be a good idea to state somewhere that distance is measured in meters and T is in seconds. But it's already up there, so I didn't restate that. So we need to ask ourselves, does the pressure depend on the depth of the diver, or does the depth depend on the pressure? The pressure depends on the depth, which means pressure is dependent and depth is independent. And it says it increases 10 kilopascals per meter, so the rate is 10. And the equation is P is equal to 10D. If we're going to graph these relations, we look at what's the independent and what's the dependent variable, and we always graph the independent variable on the x-axis and dependent on the y-axis. So if we're graphing, these ones are all just in the first quadrant, but it would be independent down here, dependent up here, or we could also make that a 4-quadrant graph. And same thing, independent on the x, dependent on the y.